The world in high summer wears a cloak of unbroken green, a color so vast and deep it seems less a shade and more a state of being. This green is the signature of a silent, relentless operation, the outward sign of a miraculous alchemy happening in plain sight. To understand the fire of autumn, one must first understand this green peace that precedes it. The story does not begin with a change, but with a constant, the diligent, sun-drunk life of a leaf at the peak of its power. Walk into a woodland in August, beneath a canopy so thick it turns the air beneath it a cool, dim jade. Reach out and pluck a single leaf, something broad and simple like a maple or an oak. To your eye, it is a green thing, perhaps veined, perhaps textured, but essentially a flat plate of color. In truth, you hold in your hand one of evolution's most elegant factories, a miniature power station that runs on light. Its architecture is a masterpiece of efficiency. The skin is transparent, a window pane designed to admit the sun. The underside is dotted with microscopic pores, breathing gates that swing open to drink carbon dioxide from the air and swing shut to hold precious water within. Inside, arranged with geometric precision, are layers of cells packed with hundreds of tiny, lens-shaped capsules called chloroplasts. And within each chloroplast, millions upon millions of molecules absorb the very stuff of sunlight. These molecules are chlorophyll, and they are the engine of our world. Chlorophyll is a pigment, a chemical compound exquisitely tuned to the physics of light. Sunlight, white light, is a crowd of colors traveling together. When this crowd strikes a chlorophyll molecule, the pigment acts as a selective bouncer. It eagerly grabs the vibrant, energetic reds and blues, pulling them inside. But the greens, the middling wavelengths, it turns away. They are reflected. This rejection is what we see. The leaf is green not because it is full of green, but because it is full of a substance that rejects green, sending it bouncing back to our eyes. But this is no mere aesthetic trick. The captured red and blue light is pure energy, and chlorophyll uses this energy to perform a feat so foundational we often forget its wonder. It builds food out of air. The process is called photosynthesis. Put simply, it is the art of using light to stitch atoms together. The raw materials are humble: carbon dioxide, a gas we exhale with every breath, and water, drawn up from the soil through miles of hidden roots. The energy is sunlight, channeled by chlorophyll. Inside the bustling chloroplast, the energized chlorophyll splits the stable water molecule, a feat akin to tearing apart a magnet. This act of solar force liberates hydrogen and oxygen. The oxygen, a happy byproduct, is released back into the atmosphere through those breathing pores, filling the air we need to live. The hydrogen, now charged and unstable, is immediately combined with carbon dioxide. From this union, a new sweet substance is forged: glucose, a simple sugar. This sugar is the tree's sustenance. It is the carbohydrate that fuels its growth from a sapling to a giant, that swells its fruits and hardens its wood. Every ring in a tree's trunk, every bud on its branch, is built from sunlight that passed through a chlorophyll molecule. All summer long, this is the leaf's single purpose: to house this green machinery, to capture light, and to spin gold from straw.
To keep this factory running, the tree invests an enormous portion of its energy. Chlorophyll is not a stable compound. It's fragile, degraded by the very light it captures. Imagine a painter trying to keep a mural bright under a blazing sun, the colors fading even as he applies them. So it is with the leaf. It must constantly manufacture fresh chlorophyll, a never-ending task that requires a steady stream of nutrients flowing up from the roots and the sugars flowing back from the leaf itself. This flow is the leaf's lifeline, and the tree maintains it with precision. The green we see is not a static coat of paint, but a dynamic, living river, perpetually renewed. And yet, all through this verdant rain, other colors are present, waiting in the wings. The chlorophyll is so dominant, so brilliantly abundant, that it masks them completely. Sharing the chloroplasts with the green pigment are families of pigments called carotenoids. These molecules reflect yellow and orange light. You know them well. They give the carrot its rusty hue, the corn kernel its sunny glow, the daffodil its trumpet of gold. In the leaf, they are not idle. They serve as a support team, capturing wavelengths of light that chlorophyll misses and passing that energy along. More crucially, they act as a sunscreen, absorbing and dissipating the violent excess of a midsummer sun that would otherwise bleach and destroy the delicate photosynthetic machinery. They are essential workers, but all summer their labors are invisible, their colors overwhelmed by the roaring green tide of chlorophyll. There is another group, pigments called anthocyanins, that are not present in summer. They are the reds and purples, and they will be created for a special purpose later under different circumstances. For now, the stage is set. Green, and only green, holds the spotlight. But the Earth turns on its tilted axis, and no rain lasts forever. The change begins not with a shock, but with a subtle shift. The days, once long and languid, begin to contract at their edges. The sun's arc across the sky sinks lower. Its light, though still bright, takes on a slanted, golden quality. The nights grow longer, cooler, and carry a new crisp depth to their darkness. The tree is exquisitely sensitive to these cues. It does not consult a calendar. It measures the world directly. The diminishing light and the dropping temperatures are a clear signal, a warning written in the very fabric of the environment. Winter is coming. And winter is a crisis for a broad, thin, water-filled leaf. In freezing conditions, water turns to ice. Ice crystals are sharp. They expand. They rupture cell walls from the inside out. A leaf is a vast, damp expanse, perfect for catching sun, but also for losing moisture. With the ground frozen, the roots cannot replace lost water. A tree covered in its summer foliage would essentially be a gigantic desiccating sail, vulnerable to fatal water loss and catastrophic cellular damage from frost. The tree's strategy is not to endure, but to retreat. It must shed its vulnerable leaves and retreat into the hardened, dormant safety of its trunk and branches. This process of controlled, seasonal death is called senescence. It is not a chaotic collapse, but an orderly dismantling, a careful salvage operation. The first step in this great shutdown is taken at the very place where the leaf meets the twig. Here, the tree begins to build a special layer of cells, a barrier known as the abscission layer. Think of it as a slowly closing valve and a pre-cut dotted line all in one. Its construction is gradual. As it forms, it begins to constrict the vital pipelines, the veins of xylem and phloem that connect the leaf to the organism. The xylem, which delivers water and minerals from the roots, is pinched shut. The phloem, the sugary superhighway that exports the leaf's product to feed the rest of the tree, is also blocked. The leaf finds itself increasingly isolated. The steady stream of water and raw nutrients from the roots slows to a trickle and then stops. Crucially, the exit for its own product, the sugar it makes, is sealed.
This isolation is the pivotal event. Inside the leaf, the factory is still receiving sunlight. The chlorophyll, as it always has, continues its work. But now the sugars it produces have nowhere to go. They begin to pool in the leaf tissues. More importantly, the supply line for renewal has been severed. Remember, chlorophyll is perpetually fading under the sun's glare and must be constantly remade. The materials and energy for that remaking, the nitrogen, the magnesium, the steady flow of sugars from elsewhere in the tree, can no longer reach the leaf. Production of new chlorophyll grinds to a halt. Meanwhile, the existing chlorophyll molecules, the seasoned workforce, carry on until they're spent. One by one, they absorb their last photon of light, catalyze their last reaction, and then break apart.
They're not washed away, they're taken apart, and their valuable components, most importantly the nitrogen atom at the center of each molecule, are carefully broken down and shipped back into the twig for storage and reuse next spring. The green, the mighty, all-conquering green, begins to fade. It drains from the leaf like color from a tired face. It is a slow retreat, first from the edges, sometimes along the veins, sometimes in patches where the cellular shutdown began first. And as this great green veil withers and thins, the world beneath it is slowly revealed. The carotenoids, the loyal yellow and orange pigments, have been there all along. They are more stable than chlorophyll, they do not break down as quickly, and they are not as nutrient-rich to salvage. So as the green fades, these hidden hues emerge, as if from a receding tide. The gold of the carotenoids, once invisible, now shines forth, illuminated by the autumn sun. It is a revelation, not a creation. The first colors of fall are not made in autumn, they are simply uncovered. The patient understudies finally taking their bow after a long season in the shadows. This is the beginning of the unveiling, the first quiet note in a brilliant symphony of light. The factory is closing, but its final act will be its most spectacular. The slow fading of the green is a quiet revolution. It begins at the edges, in the serrated margins of a maple leaf, or between the veins of an oak, as if the color is seeping back into the tree's bones. What was once a monolithic expanse of green becomes a patchwork, a living map of withdrawal. But this is not a story of mere abandonment. The tree is not shedding its leaves, it is conducting a meticulous salvage operation, one of the most sophisticated recycling processes in the natural world. The leaf, in its final weeks, transforms from a food-producing engine into a treasure chest of precious resources, and the tree is determined to reclaim every valuable scrap. Inside the leaf, as the chlorophyll breaks apart, a complex and orderly disassembly begins. Think of a skilled crew dismantling a ship in dry dock, carefully removing every reusable piece of brass, every length of good timber, before the hull is left to its fate. The leaf cells are now cut off from the tree's main supply lines by that tightening abscission layer. They're on their own, living on their dwindling reserves. Their final task is not to create, but to deconstruct and export. The most valuable prizes are the nutrients, nitrogen, phosphorus, and potassium, the core elements of life. These are the building blocks of proteins, enzymes, and DNA, and they are in limited supply in the soil. The tree cannot afford to let them flutter away on the wind with a dead leaf.
So specialized enzymes go to work. They are molecular knives, slicing apart the large, complex molecules that make up the leaf's machinery. Chlorophyll, with its precious magnesium atom at the center, is taken apart. The magnesium is stripped out and added to the salvage pile. Proteins are broken down into their constituent amino acids and then further, releasing the valuable nitrogen they contain. The cellular contents are simplified, broken down into mobile packets of nutrition. This salvage is then actively pumped back across the slowly closing gates of the abscission layer into the safety of the twig. There, these nutrients will be stored in the living tissues of the bark and the roots, held in reserve until the signal of spring calls them back into service to build new leaves. This is why autumn leaves, by the time they fall, are often pale shadows of their mid-season selves, not just because the color is gone, but because much of their substantive mass has been vacuumed out. They are architectural shells, their interiors hollowed of their most valuable furnishings. As the green chlorophyll is carted away and the yellow carotenoids stand revealed, another layer of color begins to assert itself. This is where the story moves from simple revelation to active creation. Remember the backed-up sugars? With the phloem veins blocked, the glucose produced by the leaf's last gasp of photosynthesis has nowhere to go. It concentrates in the leaf tissue, a sweet, trapped bounty.
In the presence of bright autumn sunlight and cool nights, these sugars undergo a chemical transformation. They become the raw material for a new family of pigments, the anthocyanins. If carotenoids are the old guard waiting patiently in the wings, anthocyanins are the flashy newcomers painted onto the stage at the last moment. They are not present in the summer leaf. They are manufactured in the leaf's autumn death throes. They dissolve in the watery cell sap, flooding the vacuoles with brilliant shades of crimson, ruby, violet, and magenta. Their purpose is less clear than that of the other pigments, but several compelling theories exist. They may act as a kind of antifreeze, protecting the leaf's delicate cellular machinery just a little longer as the salvage operation continues. They may serve as a sunscreen, shielding the vulnerable nutrient-stripped cells from harsh light at a time when they can no longer repair damage. Some scientists believe the brilliant reds may even act as a warning to insects, signaling that the leaf is defended or of poor nutritional value, or perhaps as a beacon to fruit-eating birds. But for the human observer, their effect is purely spectacular. They are the artists of autumn's most fiery hues. A super maple, bathed in autumn sun and chilled by frosty nights, becomes a torch of scarlet because of these manufactured anthocyanins. They mix with the uncovered yellows of the carotenoids to create blazing oranges and luminous bronzes. Now the landscape becomes a painter's palette, and the specific mix of colors on any single tree, or even on a single branch, tells a story of its specific conditions. A tree on a sunny hillside, experiencing sharp contrasts between warm days and cold nights, will often produce more anthocyanins, resulting in dramatic reds and purples. The same species in a damp, shaded gorge, where nights are milder, might lean towards the gentle golds and bronzes of the carotenoids. Stress plays a role. A summer of drought can sometimes intensify fall color, as trees are stressed into an earlier senescence. The chemistry of the soil, particularly its acidity, can influence the shade of the anthocyanins, pulling reds towards more bluish purples. This is why autumn is never the same twice. It is a real-time living canvas, painted by the intersection of a tree's genetic blueprint and the unique weather story of that particular year. But the brilliance is fleeting, a final glorious blaze before the end. The salvage operation reaches its conclusion. The abscission layer completes its work, transforming from a barrier into a line of weakness. Its cells dry and become corky. On the tree side, the layer seals itself with protective resins and gums, readying the scar that will become next spring's leaf bud. On the leaf side, the connection is severed. Then one day, a breeze stirs, not a summer zephyr, but a cooler, insistent wind from the north. It tugs at the leaves whose bonds have been carefully pre-cut, and with an almost respectful silence, the leaf detaches. It spirals down, a dry, light thing, its work complete, its treasures returned. It is now just a shell of cellulose, a ghost of its former self, containing only what the tree could not use or did not need. It will carpet the forest floor, where a different chapter of the story begins, one of decay and return, as fungi and insects and bacteria break it down, slowly returning its remaining substance to the soil to feed the roots of the very tree that let it go. The circle, even in this letting go, remains unbroken.
And so, the leaves fall. They drift down in a silent colored rain, spinning on their stems like rudderless boats, coming to rest on cold earth. The ground, once a carpet of moss and shadow, is now a breathtaking mosaic of gold, red, and bronze. It crunches underfoot, a dry, fragrant sound that is the very essence of autumn. But this is not the end. It is a transformation. The leaf story, so vivid in the tree and so brilliant in its descent, now enters a final, quieter phase. It becomes a gift to the earth from which it came. Look closely at this fallen leaf. It is light, crisp, a skeletal version of its former self.
The tree has reclaimed the good china, the nitrogen, the phosphorus, the valuable metals and proteins. What remains is the wooden frame, a tough, complex web of cellulose and lignin. This is the leaf's final body, and it becomes a world unto itself. On the damp forest floor, it is immediately colonized. You cannot see them with the naked eye, but an army of decomposers is mustering. Thread-like filaments of fungi called hyphae creep over and into the leaf, secreting powerful enzymes that can digest the tough cellulose. Tiny soil creatures, springtails, mites, and woodlice scurry across this new landscape, nibbling and shredding the material into smaller and smaller pieces. Bacteria join the feast by the billions. This process is slow, elegant decay. It is not a death, it is a dismantling for reuse. The carbon that the leaf once pulled from the air as carbon dioxide, the very carbon woven into sugars by sunlight, is now being broken down. Some of it is released back into the atmosphere as carbon dioxide by the breathing of all these tiny organisms, but much of it is incorporated into their own bodies and, crucially, into the soil. The leaf is becoming humus, that dark, rich, sweet-smelling layer of earth that is the lifeblood of the forest. In this humble form, the leaf's essence is recycled. The nutrients the tree did not reclaim are broken down further, dissolved by rain, and taken up by the vast, hungry network of the tree's own roots, or by the roots of seedlings and ferns. The circle is literal and profound. The leaf that once made food from air and light now becomes food for the tree that bore it. This is why an autumn forest floor smells the way it does, that spicy, sweet, deeply earthy scent. It is the smell of chemistry, the smell of molecules being unstitched and rewoven. It is the smell of memory, too. For in that chemical soup of decay are the very signals that will whisper to the tree through the long winter. The soil, enriched and changed by the leaf fall, cradles the roots and holds the story of the season past. And what of the tree, now standing bare? It is not dead, but dormant. It has entered a state of profound rest, a kind of living stillness. Without leaves to power its systems, its metabolism slows to a mere whisper. The sap, which once raced through its veins, withdraws and thickens. The tree enters a fortress-like state, its bud scales waxy and tight, its bark a hardened shield against the cold and the hungry mouths of winter animals. All its living energy is concentrated in the roots, the trunk, and the protected buds that hold the blueprints for next spring's leaves. It waits. It endures the ice, the wind, the deep silence of snow. It is gathering its strength, living off the stores of sugar it packed away during the summer glory, and the nutrients it so diligently salvaged during the autumn dismantling. This is the hidden connection between the fiery spectacle of October and the green miracle of April. The brilliance of fall is funded by the summer's work, and it directly fuels the spring's rebirth. The tree's decision to sever the leaf is not a loss, but a strategic investment in survival. The reds and golds we so admire are, in a very real sense, the visible signature of that survival strategy, the flashing lights of a biological factory in careful, beautiful shutdown. The fallen leaf is not trash. It is both the discarded shell and a future meal ticket returned to the earth as payment for seasons to come. So when you stand in an autumn wood, you are standing at a crossroads of time. You see the past, the summer's labor captured in fading color. You see the present, a moment of breathtaking beauty born from letting go. And if you look closely at the tight buds on the branches and the dark soil underfoot, you can see the future, the promise of green, waiting patiently for its turn in the sun. The cycle is eternal, and each stage depends utterly on the one before. The fall is the necessary bridge between the abundance of summer and the renewal of spring, a bridge painted in the most astonishing colors on earth.
And so we arrive at the heart of the mystery, not with a question, but with a feeling. That quiet awe that descends when you look up through a canopy of flaming maple or a golden birch and understand, for a moment, that you are witnessing not just beauty, but a conversation. A conversation between a tree and the earth, between light and time, written in a language of color. We began with the deep, constant green of summer, the color of work and creation. We saw how that green was both a mask and a miracle, a pigment so busy capturing sunlight that it hid the quieter yellows and oranges that had been there all along. We followed the tree as it sensed the world tilting away from the sun and began the careful economical process of shutting down its leaf factories. We watched the green fade, not from carelessness, but from a deliberate salvage operation, pulling every precious atom of nitrogen and magnesium back into the safety of the twig and root. We saw the hidden carotenoids finally step into the light, their patient gold unveiled. We witnessed the creation of new, brilliant reds from trapped sugars, a final flare of chemical genius before the end. We then saw the release, the leaves spiraling down, not as dead waste, but as gifts. On the forest floor, they entered a new life as food for an invisible world of decomposers, slowly becoming the very soil that feeds their parent tree. The tree, now bare and still, entered its deep winter sleep, living on the stores it had saved from summer and reclaimed in autumn, holding the promise of spring in its tightly scaled buds. This is the full, magnificent circle. It is a story of cause and effect so seamless it becomes a single breathing process. Because the sun's path changes, the tree receives a signal. Because it receives that signal, the tree seals the leaf's base. As a result, chlorophyll breaks down and is recycled. Consequently, the yellow carotenoids are revealed. Meanwhile, trapped sugars form red anthocyanins. Finally, the leaf falls, leading to the enrichment of the soil and the dormancy of the tree, which ultimately allows for its survival and the rebirth of spring. The why of fall colors is not a single scientific fact. It is a layered narrative of survival strategy, chemical magic, and planetary rhythm. It is about resource management on a grand scale. The tree is a brilliant economist of life, investing, harvesting, and recycling with flawless timing. It is about physics, the interaction of light with molecules, the reflection of specific wavelengths into our waiting eyes. And it is about sheer, wondrous coincidence that this process of survival happens to paint the world in hues that stir our souls. When you understand this, a walk in the autumn woods changes. You're not just looking at pretty leaves, you are reading a biography. That scarlet maple is a testament to sunny days and cold nights. That pale yellow hickory speaks of a gentler shutdown. The deep purple of an oak is a tale of soil chemistry and stored sugars. The forest becomes a library of the year's weather, each tree a volume written in pigment. This spectacle is the gift of the temperate world, where seasons are distinct and trees must adapt or perish. It is a lesson in letting go with grace and purpose. The tree does not cling, it assesses, it acts, and it releases, trusting in the cycle, investing in its own future. In their blazing finale, the leaves are showing us the elegance of release, the beauty in transition, and the quiet, enduring strength found in resilience. They remind us that endings are often brilliant, and that from every seeming loss, the ground is prepared for a new beginning. So the next time you catch your breath at a hillside clothed in fire, remember, you are seeing life itself in its most urgent, clever, and gorgeous transition. You are seeing the green engine of summer quietly powering down, and in its glowing embers, you are seeing the promise of the green to come. It is not a death, it is a brilliant, necessary, and deeply intelligent part of living. And that may be the most beautiful lesson of all.